Hey everyone, I'm Ake, Head of Developer Experience at Chainstack, the leading Web3 infrastructure provider. With 7+ years in blockchain, I'm in constant hands-on build mode in this fast-paced Web3 environment. Today I'm not just walking you through building a pump.fun bot on Solana, I'm sharing my research approach for tackling unfamiliar Web3 projects. I've been doing this for many years. If you'd like to dive straight into the bot's code and setup, check the links in the video description. But if you want to learn how to rush through research in Web3 development and come back with a result, stick around. I'll show you how to do just that effectively and build in this fast-paced industry. Let's go. Okay, let's talk the approach to tackling Web3 projects. We'll call it the speedrun method, which is how gamers rush through their video games in their backlog. The speedrun concept. Imagine you're playing a game you want to complete quickly. You're not concerned with taking in on every detail. You're clicking through all the dialogues. You kind of go skip on all the cutscenes. Your goal is to reach the final credits as soon as possible. Why this approach works in Web3? It mirrors the fast-paced nature of the Web3 industry. It keeps you engaged with consistent challenges, and it keeps giving you kind of dopamine hits on completing every mission. It allows you to complete mission after mission efficiently. So the process, rush through the project, focusing on the core functionality. Don't worry about distinguishing between main missions and side quests. You'll figure it out later. Aim for a working product first, optimize later. The benefits of the speedrun approach. You'll quickly achieve a fully functional project. You'll be able to maintain the momentum and your interest throughout the development. You'll get the results fast, and this is how Web3 works. After the speedrun completion, you can do everything else if you feel like it. For example, you can learn the foundations you might have missed during the run. You can optimize your code. Think of it as New Game Plus. You can use your working project as base for further development, like building a full product. P.S. I'll make occasional references to Ethereum, but don't worry if you're unfamiliar with Ethereum, you will still be able to complete this project fine. You'll find this process a lot easier than you might expect. And final note, creating this video tutorial took about 3 times longer than doing the actual project. So that's how easy the project is. Let's go. Okay, so let's dive into what we are actually building here. We're talking about pump.fun, and we are going to create a trading and sniping bot for it. Now, if you're not familiar with pump.fun, it's this project on Solana. The basic idea is you can create your own coin, could be a meme coin, could be whatever. When you do that, it sets up this bonding curve contract or a program, they call it on Solana. This is where you can trade your new tokens. Once your token hits a certain level of liquidity on the bonding curve contract, it moves over to an exchange like Radium. Pump.fun is actually pretty big. We're talking millions in daily volume. Everyone's been talking about it, and of course, like everything successful in Web3, there are already clones popping up for it. Also, the pump.fun UI, let's just say it's not for everyone. It's not for me for sure. I barely used it myself. I may be open to 10 times tops while building this bot. It's never going to be my preferred method of interacting with a set of pump.fun contracts. Secondly, and this is key for us, in Web3, we always want to get as close to the model as possible, right? We don't want to rely on someone else's interface. We want direct access to the on-chain programs. Now, pump.fun doesn't have any APIs out there. Some have built their own microservice platform software as a service platforms with APIs to interact with the pump.fun programs. So those could be used. We, however, are going to build a bot that bypasses all the third-party stuff. No pump.fun UI, no external APIs. We are talking directly to the Solana programs with our own Python code and through a Chainstack node. And yes, we are doing this in Python. And if you can build a bot for pump.fun, you're basically set up to do the same for any similar project or clone out there. So let's do it. Alright, let's talk about setting up our own interaction with pump.fun. Think of this like playing a video game with different difficulty levels. We have 4 levels of interaction here, so let's walk through them. Level 1, easy mode. This is your basic entry-level stuff. You're just using the pump.fun frontend to interact with their programs. Simple, slow, not for us. Level 2, normal mode. This is a bit more fun. You look around and you find these third-party APIs like Pump Portal. These guys pop up when you're searching for pump.fun APIs, and here is how it works. They have their own set of APIs that interact with pump.fun's on-chain programs. They construct the transactions for you, you sign the transaction, then you send it back on-chain through them. Now, they do take a fee for this service, about 0.5% per trade, not too bad, but here's the thing. Is it true Web3 build, or do you really want to rely on someone else's APIs? Today it's 0.5%, but what if tomorrow they jack it up to 50%? I mean, the Pump Portal guys, they seem like really great folks. They built a solid service. I don't think they are going to do this, but you get my point, right? You want to rely on your own infrastructure. Level 3, normal plus mode. Normal plus mode. This is where you're still using the third-party API, but with your own RPC node. You get the coin info from the Pump Portal API. You subscribe to their WebSocket for all the newly minted coins. They construct the transaction for the coin you want to buy and add their fee. And here's where the normal plus mode kicks in. Instead of sending the transaction through the Pump Portal guys, through their API, you sign it and submit it through your own Solana node. This is where you can start using some serious firepower, like Chainstake Solana RPC nodes or Chainstake Solana trader nodes. These propagate transactions to the validators as fast as possible with priority, which is going to be a lot better than the easy mode and the normal mode. But here is level 4, expert mode. This is the real deal. Here's what you do. You bypass the interface, the pump.fun interface completely. You ditch all those third-party APIs. You build your own Python bot, or any bot really, that interacts directly with the pump.fun programs. You use an RPC node or Solana trader node. Again, Chainstake provides all of those. And this is the level we are going for. We are going to speedrun this game on expert mode, and the payoff is going to be big. By going this route, we are not just building a bot. We are gaining the knowledge and skills to potentially build our own microservices like Pump Portal, and we'll be relying on our own infrastructure. So let's get technical. Okay, we are rushing through this game, so the first step is to find the program address. Here is what we need to do. Go to pump.fun and pick any random coin. Copy the coin's address, paste it into an explorer like SolScan, look for the first mint transaction and grab that hash. From that transaction, we can find the pump.fun program ID. That's the program that creates all coins on pump.fun. So now we have our program ID, but there is a catch. How do we interact with this? Now we have this program ID, but it's just a bunch of useless bytecode to us right now. We need a key to read this. It's kind of like needing an ABI for a smart contract on Ethereum. Time for an educated guess. Because we are speedrunning through this, we are going to make an assumption. Most Solana programs are built using the Anchor framework. So let's go with this. We need an IDL. In Anchor on Solana, instead of an ABI on Ethereum, we have something called an IDL, Interface Description Language. This is our magic key to the program. It describes how to interact with the program and all the data structures in there. So let's find the IDL. Now, in a perfect world, we'd find this IDL verified on the Explorer. Like you might find a verified smart contract on Etherscan, for example, on Ethereum. But pump.fun, of course, does not have that. There is no verified IDL. And as a quick side note, if you are curious what a verified program with an IDL looks like, here is an example. But that's not our pump.fun program, unfortunately. So here we are needing this IDL, our major key to unlock the pump.fun program, but it's not readily available. We need to find another way to get our hands on. So let's find the coveted IDL. Alright, our mission is to get our hands on that IDL for pump.fun. So let's walk through this step by step. Here is how we deal with IDLs. Depending on how pump.fun has set up their app, this IDL could be hiding in one of two places. It's either on the server side, if it's on the server, we are out of luck, can't touch it. Or it's on the client side. This is what we are hoping for, and it's the easier route for developers, and this is how most web applications have it. So let's see what the pump.fun web app loads onto our machine. Here is what we do. Head over to pump.fun, right click and select inspect to open the Chrome developer tools. This lets us to see all the calls being made. Now we can just manually explore the source to find our IDL, but here is a quick trick that works for most web apps on Solana built using Anchor IDL. Go to the source tab in DevTools, and here the shortcut, search for this JSON parse, and if we are lucky, this should lead us straight to the IDL. And as a side quest, while we are here, keep your eyes peeled to what you see. You might stumble upon some other stuff like unprotected RPC endpoint, free for all to use apparently, which is what we have here, and the front-end API for pump.fun coins that allows you to retrieve the coin information if we wanted to use this, but we're not going to. So now we have our previous guesses confirmed. Pump.fun is built with Anchor, and they have the IDL right there on the client side, and this is going pretty easy so far and pretty good. The bigger picture, however, is don't think we just got super lucky here. This is actually pretty common in the Solana world. Most applications follow this pattern, so these tricks can yield quite a bit. What's next? We've got our IDL, which means we have the key to interact with the pump.fun's on-chain program, so let's architect our bot. Okay, so now we have the IDL for pump.fun. It's like getting the English version of the Japanese RPG you've been dying to play. Now you can actually make some progress. Let's talk architecture. I know we are doing this pretty late in the game, but remember, we are speedrunning this. So here is what we have in our toolkit so far. Third-party endpoints, Pump Portal WebSocket that they provide for free. Theoretically, we could use that as well. Check the scripting tutorial in the GitHub repository in the video description if you want. We have that front-end coin API we found while snooping around pump.fun with Chrome developer tools. And of course, we are not going to use any of this. Our architecture is going to be simple. The pump.fun program does three main things. It creates coins, it lets you buy coins, it lets you sell coins. So we are going to mirror that in our bot. Here is the plan. First, listener script. We'll create a script that subscribes over WebSocket to the program ID, and this will get us all the coin information, all the new coins that are being printed. Then we'll have the buyer script. The buyer script jumps into action when our listener script spots a new coin and buys it. And then we have a seller script, a script that sells the coins that we hold. We are going to start by building these three scripts separately. It's like building the individual parts before we put it all together. And we are going to start with the listener script that listens to all the create events. It's going to be our foundation, the first piece of our pump.fun trading bot. So let's do the create listener script. Okay, so let's build our first create listener. What we need to do first is set up a way to listen to the Solana program. We are specifically looking for the create event, which happens when a new coin is minted. Let's start by using the log subscribe method. Why? Well, when we look into our IDL, we can see there is a create event structure in there. This tells us the events are being emitted by the program. Now remember, we are trying to speedrun this, so we are going for the easiest route. The log subscribed method lets us connect our WebSocket to the program ID mentions. So we run this method, and we start seeing some output. In the raw logs, we can spot program log instruction create. That's our signal that the new coin is minted. Now we need to filter the noise. We are getting all sorts of events here. Create, sell, buy, probably others too. But we're coin hunters, so we need to filter out everything except those program log instruction create messages. That's our target. And here the tricky part. That raw output, it really doesn't tell us much about the coins themselves. It doesn't provide us with the name or URI or none of the good stuff of the coins. So to get that info, we need to decode the raw output using our IDL. If you poke around in the Anchor docs, you will see that just like Ethereum uses 4-byte signatures for function identifiers in Solidity, Anchor uses 8-byte identifiers for each instruction. This is crucial for our next step. Armed with our IDL and this 8-byte offset knowledge, we are going to create a script that does two key things. It listens to the pump.fun program, prints out the decoded output for every new coin, and this script is going to use the IDL to understand the raw data, and is going to use that 8-byte offset properly to decode everything. And there you have it. We've gone from a raw messy data to a clean decoded stream of new coin information. Looks like we're doing good progress. At this point, we are already not relying on any third-party APIs and getting the data directly from source. Now let's proceed further and try a buy transaction. Okay, so we have our create event listener up and running, decoding and printing all the coin info. Now we are switching gears and getting into the right transaction territory. Until now, all we've been doing is doing read requests, not changing the state of the chain. So how do we construct a buy transaction on Solana with pump.fun? Here's our plan. First, we try to figure out how a buy transaction actually works. Let's use the Solana get transaction method on a buy transaction. We will grab the signature or transaction hash, get the data and decode it using our IDL and that 8-byte anchor offset that we learned about previously. Now that we have decoded transaction output, let's have a look. We can look at it side by side with the IDL. And okay, looking at this, you kind of feel, I do, feel this is a wow moment. Looks like there is just a lot of accounts involved in a single byte transaction. There is global, fee recipient, mint, bonding curve, associated bonding curve, associated user, system program, token program, rent, event authority program. And looking at those, this seems to be a mix of three categories. There is pump.fun programs like bonding curve. There is Anchor framework related accounts like global and event authority. And there is default Solana system programs. So at first look, this might feel overwhelming and seem to be not as easy as expected. But we are rushing through this, so the obvious idea is to try and figure out the relationship between all these accounts. A side note, it's kind of funny that we are trying to figure out the architecture of pump.fun this late into the game, but that's our speedrun approach. Might seem counterintuitive, but it works. Okay, so how do we figure out the relationship? We are going to run the Solana get account info method on each of these addresses. And in the output, we are going to look for two things. One is it executable? True means it's a program. And two, what account owns it? Pro tip here, if you're feeling overwhelmed, you could dump the entire output of all the get account info method calls to Cloud AI or anything similar. Ask it to draw the relationships between the accounts, but be careful, however, and verify. It's certainly error prone. Now we do quick fast forward, and here is the architecture of pump.fun that we've been able to figure out based on the buy transaction in all the relationships. The green ones are the pump program owned by the pump.fun accounts and programs. And the only one that is executable here is the pump program itself, the program ID that we've been using so far. The pump program owns pump global, and pump global, again, if you look at the Anchor docs, they briefly mention global account. And the global account seems to be an account that holds different variables, like who received the fee, what the event authority is, and again, event authority itself is also mentioned in the Anchor docs briefly, because it's a part of the Anchor framework that's responsible for emitting the events and verifiably doing so. But it's blue here because it's not owned by the pump program, and neither is fee recipient. So all the blue ones that start with system here on the scheme are not owned by the pump program. So the global account is owned by the pump program and has the fee recipient and the event authority set in it. And then the pump bonding curve is owned by the pump program, and there is a separate associated bonding curve which is actually owned by the system, the token program. And the mint address is also, which is the address of the coin, is owned by the token program. And there is also the associated system token account, and then there is the user account also owned by Solana. So based on this, we are able to figure out that when a mint is created, a new coin is minted, there is a bonding curve account created. And to hold this new coin, the user needs to create an associated token account, which is how Solana works. And to hold this account, this token bonding curve program also needs an associated bonding curve, which again is how Solana works. Mint an associated token account, and then there is bonding curve and associated bonding curve account. Same mechanism, okay? So this is what we've been able to figure out so far. Based on all the information that we have, the decoded byte transaction and the ownership of the accounts, let's actually build the flow of a byte transaction, which is again much more complex than expected. So it turns out you actually need to interact with the bonding curve, right? Each coin has its own bonding curve construct, and the bonding curve construct in the associated bonding curve is holding the tokens that you buy, that you sell. So to be able to buy a token, you actually need first to fetch the price from the bonding curve of the token, of the coin that you are going to buy. You need to fetch the price, and then once you have this price, you need to construct your transaction. And we've already figured out all the accounts involved based on the IDL and the decoded byte transaction. You need the pump.fun program ID, which is the main executable program. You need the pump global because it sets the fee recipient and the event authority. So you need the bonding curve, and you need the associated bonding curve because it holds the tokens that you buy. You need the token address itself. You need the associated account which you create for the token that you are going to buy and hold, which is how Solana works. And you need all the system programs like event, like rent, system token program, and all of that stuff. So it's much more complex than we imagined. And also, the key thing here that we are learning by looking into all of this is that when we run our listener, it's not printing one of the key items, one of the key addresses that we need, which is associated bonding curve. We have the hash of the created event of the token, we have the name, we have the symbol, we have the address, we have the bonding curve, we have the user who created the token, but we do not have the associated bonding curve address, which we need to properly construct our byte transaction, which means we are going back to the drawing board, and we need to kind of rethink how we retrieve our create events from the chain, from the pump.fun program. We need the associated bonding curve, and we don't have it. So back to the drawing board. So how do we get the associated bonding curve? Let's first check the create event in IDL. Looking at the create event IDL, we can see that the associated bonding curve is not part of the emitted logs when the token is minted and the bonding curve is created. When we look at the create event IDL, we notice that the associated bonding curve isn't part of the emitted logs, but the bonding curve and token are minted. So how do we get the associated bonding curve address? Our first thought might be to extract the associated bonding curve from the transaction itself. Let's have a look at that process and what it might look like. We'll need to run a get transaction, decode the transaction, extract the associated bonding curve from the decoded create transaction. Sounds simple, right? Well, yes and no. Let's break it down. We need the transaction hash or signature, which we can get from our log subscribe method. We would then go back to the chain and run the getTransaction method with this hash. After getting the full transaction, we would extract the associated bonding curve, and finally we would construct the buy transaction. This approach, while feasible, doesn't look too good. Given the rate at which tokens are minted on pump.fun and Solana's speed in general, it involves a lot of requests. It's a complex construction that might not be sustainable. Remember, we are rushing through this game on expert mode, and because we are experts, we have intuition that there is a better solution out there. Kinda like you sense a secret in a spot in a game. So what if we could get the full transaction data over a WebSocket as transactions come in without any additional calls? We browse for a bit and figure out there is actually a way to do this. Enter the block subscribe method. This method, often overlooked because the Solana docs say it's unstable. Well, it's pretty stable on ChainStack thanks to our amazing engineering team, so this is not an issue for us. Here is how block subscribe works. It gets us all the blocks over WebSocket which come in very fast on Solana. It has two crucial parameters: program mentions, filters for account of a specific program, and transaction details full, which gives us the complete transaction data. That's exactly what we need. That's all what we need. Instead of sending multiple GET transactions, decoding them, and shuffling data back and forth, we simplify our process. Subscribe to all incoming blocks that mention our program ID, get full transaction data from these blocks, decode the relevant transactions using our IDL, extract all the information we need, including the associated bonding curve. This approach is lean, efficient, and gives us exactly what we need. Now that we have a neat way of getting our data, we are almost there. Next, we need to figure out how to fetch the token price from the bonding curve to be able to buy it. Alright, now that we have our associated bonding curve, let's tackle our next challenge, which is fetching the token price. I have a little side note on that. While I was working on constructing the buy transaction and checking the account relationships and generally faffing around, I got curious about how the pump.fun web application actually fetches the prices. And here's how you can do it. So it's also on the client side as per usual. Go to the pump.fun web app and click on any coin. Open Chrome Developer Tools by doing a right click and then inspect, and check out the network tab. You'll notice it's making a few different types of calls, but one call stands out. It's making constant calls with the get account info method to a specific contract. That contract is always a bonding curve account of the token that we have open. There was yet another kind of in-your-face additional proof that the price is fetched from the bonding curve. Now that we can fetch this data with the get account info, right, which is a simple call, we need to deserialize it. This is where we go back to our discriminator again and check our IDL as well. But first, let's talk the discriminator. It's actually high time we started doing the discriminator calculation. We will need it for the buy and sell transactions later as well. Calculating the discriminator is pretty straightforward. Just check the Anchor docs for the description on how it's calculated and create a basic Python script to calculate the 8-byte unique entry point. And as always, pro tip, you can probably use a Cloud AI to generate the script for you. Just dump that Anchor chapter in it and ask to create a simple Python script for the discriminator calculation. So now the IDL again. First, look at the IDL of the bonding curve, specifically the entry for the bonding curve account. You'll see a structure with fields like virtual token resource, virtual solar resource, real token resource, real solar resource, token total supply, and complete. We need to fetch this data and properly deserialize it using the discriminator and our IDL. And a quick note on decimals. It's something that tripped me up initially. While Solana SPL programs usually have 9 decimals, the pump.fun tokens actually have 6 decimals. So you can verify this by looking at the tokens in your wallet, and I have a lot of them by doing the testing with the script. And keep this in mind, the 6 decimal thing is crucial for accurate calculations. So once we have all the data decoded, we can calculate the token price. And the formula is pretty simple. Token price in Sol is virtual Solana resource divided by virtual token resource. You can also double check your calculation against the actual price on the pump.fun web interface. It never hurts to double check, and this will generally let you know if you're fucking in the right direction and that your calculations are correct. And there you have it. Now we are armed with everything we need. We can fetch the associated bonding curve, we can get the token price data, we can deserialize the data, we can calculate the actual token price. So now we should be able to construct the byte transactions, and we are almost at the finish line. Alright, now we have all the pieces. Time to put them together and construct our byte transaction. Let's break down what we already have. We have three types of addresses that we operate with. We have pump program constants, pump global, which holds the fee recipient and the event authority. We have pump fee recipient, we have pump program ID, we have pump event authority. And then we have Solana system accounts, system program account, system token program, and system rent. And then we have token specific data that we get from listening over block subscribe. And these are mint, the address of the token, the bonding curve that we use to fetch the token price, associated bonding curve, which holds the mint token, associated token account, which we create to hold the token, and then the user address. Now let's walk through how we construct and sign the transaction. We connect our WebSocket to the Solana network. We use the block subscribe method, and remember, it gives us full transaction details, and we extract all the necessary token data for the newly minted tokens. Then we decode this data using our discriminator, which we know how to calculate for the byte transaction. Once we get the printed coin, we fetch the bonding curve data and calculate the price. Then we use all this information to construct our byte transaction. I also added the slippage in there so that it can be useful, especially considering the fast token movements on pump.fun. And a quick note on timing. Because Solana is lightning fast, I've added a cooldown period in the script, and here is why. We get the coin mint and all its details, but to buy this token we need to create an associated token account to hold this token. Sometimes you might get errors because the information from the mint event hasn't fully propagated yet. I've set the 15-second cooldown period, but feel free to experiment with this. It's also the perfect opportunity to use the Solana trader nodes on chain stack, which significantly speed up your token buying process. And there you have it. Now let's do a sell script. Alright, we've mastered the buy script, and now it's time to flip the coin and do the sell script. It's basically the same, but the other way around. Here is what stays the same. We are still working with the pump.fun program on Solana. We are using the same global constants and system accounts. We are still interacting with the bonding curves and associated token accounts. And here is what we are not doing. No event listening. Unlike the buy script, we are not listening for new token creation events. We already know which token we want to sell. Here is what we need. The address of the token we are selling, the bonding curve and associated bonding curve for this token. We still fetch the price from the bonding curve. Just like in the buy script, we need to set a slippage tolerance for our sell order. This accounts for potential price changes, as always, between when we submit our transaction and between when it's processed. We're using the pre-calculated discriminator for the sell transaction. Remember how we calculated this for the byte instruction. Same concept, different instruction. Just like in the buy script, we are working with the 6 decimal places for the pump.fun tokens, which is always crucial for accurate calculations. With all these pieces in place, we construct the sell transaction, and it's very straightforward. We take all our information, the token address, the bonding curve details, price slippage, and our pre-calculated discriminator, and put them together in a Solana transaction. Now let's put everything together and create the actual trade bot. Alright, now let's put it all together and create our very own trading and sniping bot. Our trading bot, which we'll call trade.py, is essentially a combination of all the scripts we have created so far. Listening to the create events, extracting the necessary token information, executing buy transactions, executing sell transactions. Let's also add some login to keep track of our bot's activities, which is always a good idea. So we'll have the token database, we'll create a separate file in the trades directory for each token we encounter. The file name will be the token's address, creating a simple database of all tokens we have interacted with. Then we'll have a trade log. We'll maintain an appendable trades.log file. For each trade, we will log the time step, action buy or sell, token address and token price, and the transaction hash. Now the global configuration. To keep our bot organized and easily configurable, we'll create a config.py file. This file will contain pump.fun addresses, Solana system addresses and accounts, the trading parameters, slippage tolerance, and the buy amount. And also the network information, the RPC endpoint, the WebSocket endpoint, and our private key for executing the trades. In its simplest form, our bot will follow this workflow. Connect to the Solana network via WebSocket, listen for the newly minted tokens, retrieve the token details, execute a buy transaction for the new token, wait for 20 seconds, and then execute a sell transaction for the same token. And that's our trading bot. Very easy. Web3 is certainly wild and fun, so let's make our trading bot fun as well. We are going to add a few flags to it. The YOLO flag. It puts the bot in continuous trading mode. The bot keeps buying and selling tokens without stopping. Then the match flag. Next, let's add the match flag for the trend watchers. With this flag, the bot scans token names, tickers, and descriptions for partial matches to the keywords that you specify. The bot only buys tokens that match your criteria. These are meme tokens, and there is always a new trend. So you can just run the bot partially matching the word, and it will trade only those tokens that match the trend. The bro flag. The bro flag takes in a user account. It follows a specific user address and buys the tokens created by that user. For example, you know that the tokens created by this user account always do well, and the dev basically never leaves the chat and you don't want to miss them. The Mary flag. Last but not least, the flag that makes the trade bot just buy the tokens and never sell. You can also combine the flags. For example, Mary and Bro will buy the tokens from the dev that never leaves the chat and never sell them. Or YOLO and Match will always continuously trade the trading tokens. Have fun! Bonus section. Take your bot to next level. Congratulations, you've made it to the end of our tutorial and your trading bot is up and running. Now let's have a little peek into what else you can do with your newfound skills. Now that you've got your trade bot working and you've even added flags to it, why stop there? You're the perfect launching point to take this project to the next level. Like turning your bot into a micro SaaS, which is software as a service platform. You can now create something similar to Pump Portal, but with your own unique twist. And this doesn't just apply to pump.fun. You can do this with pump clones or even other programs. You have the skills to research and adapt now. Just add API endpoints to your bot, create a simple documentation website showing how to use those endpoints, and you've got yourself a micro SaaS platform. I'm not going to dive into the details here, but you've made it this far, you have already done the hard part. Setting up API endpoints and a docs website is relatively straightforward compared to what you have already accomplished. Micro SaaS is seriously underexplored and underutilized in the Web3 space, and it's a low-hanging fruit. So that's an idea. Conclusion. Alright, a quick note on the power of research and rapid development. You've seen firsthand how a methodological approach to research and development can yield results. We've gone from understanding the basics to creating a fully functional trading bot, all the while learning how to research and gather the necessary information, utilize various resources and tools effectively, rapidly prototype and develop blockchain applications. This approach isn't just for trading bots, it can be applied to virtually any blockchain project or Web3 application. It's a skill that always works for me and hopefully it will work for you as well. Web3 is still very much a blue ocean, even in what some might consider a downtime for the industry. There are countless opportunities for the innovation and development. The field is wide open for creative minds to make a significant impact. So keep building and leverage the Chainstack nodes, and especially the Chainstack trader nodes that specialize in delivering your transactions fast. Be fast, grab the opportunities, keep building, and use Chainstack.